Welcome, students. In this lecture, we are going to talk about some theoretical background about vector analysis. And in this video, I'm going to talk about basic geometric vector operations and vector overlay. Well, overall, when we talk about vector operations in terms of in this GIS context, there are four different types of vector operations that we could distinguish. This is basic geometric vector operations such as calculation of distances within the GIS environment, vector overlay, vector data editing and cleanup, and calculation buffer zone. And in this video, I'm going to talk about two first types of operations, namely basic geometric vector operations as well as vector overlay. So when we talk about basic geometric vector operations, the operations that we have in mind are usually related to the computation of distances between two features. There are five different types of distances that could be calculated within GIS environment, and that I'm going to mention briefly today. Perhaps the most common one is the Euclidean distance, but there are also those kind of the distances as Manhattan distance, distance in network, topographical distance, as well as spherical distance. When we talk about computation of distances based on Euclidean distance, this is basically the theorem of Pythagoras that you have been studying during your school times and which compute basically the line, the distance between 2 points as a line in a triangular. Yeah, so this is basically the theorem of Pythagoras, and this is perhaps most common distance operation that is used in GIS environment. And this kind of approach is usually behind this algorithm is behind computation of length of a line that you could compute in GIS. So in this example, we have a line that consists of four distinguished segments, which is five, have a distances 5, 7, 3, and 4. And in order to compute the line, the length of this line, the sum of all line segments from the start to end node is computed. And line segment lengths are computed using the Pythagorean theorem. Well, when we talk a distance in a network that is shown here, here we have a distance of network. We use the distance of segments so we have first to identify the starting point and the end point of our network, and then the distance would consist of the sum of the segments that is and counted along the way between these two points. So we have to add 1 with 3, 5, and 7. Computing polygon area also belongs to the basic geometric vector operation. So this is extremely popular as well as common vector operation. So for example, when you have a polygon or such as a boundary of your country or your boundary of the study area, and you would like to compute the polygon, the area of this polygon. So how do we do this? So each of the points in our polygon has a distinct coordinates x and y, and given by the y values of each point multiplied by the differences in the x values of the following and preceding points, counting logwise. So this direction, all summed up and divided by 2. This is basically how we compute an area of polygon. This doesn't mean, by the way, that you should type in formula in GIS in calculator to do that. Those algorithms are already pre-programmed for you in QGIS and ArcGIS. but I'm giving you this background information that you would know how those operations or algorithms are functioning in GIS environment. Well, when we need to find intersection between two lines, this quite also common operation in GIS. For instance, if you have you need to find an intersection of bridge and river, or flight paths, or find combinations of new polygons with districts and land uses. The equation of a straight line applies. Yeah, so this is the straight line where we equation, which you can see here, that is have to be solved in order to find the intersection point here. Another basic geometric vector operation is a point in polygon overlay. So when you have a point like here in this image, and you have several polygons, and you have to overlay those two. So how is it performed in GIS? GIS draw a straight line in any direction from the point of interest and count the number of intersections with a polygon border. If the order of intersection is odd, the point is located in the polygon. So here you have polygon 1, polygon 2, and polygon 3. And then you can see this in this row, in this column of this table. And here is our point. We draw a straight line, and then we count how many intersections are there. So with polygon 1 is only 1, with polygon 2 is 2 intersection, and with polygon 3 are 4. 1, 2, 3, and 4. And only the polygon which has the number of intersection is odd is a polygon where the point is. Yeah, so that is how it is functioned. Well, vector overlay. This is also quite important and very, very common GIS operations. And when we talk about vector overlay, we could distinguish between points overlay over polygons, lines on polygons overlay, and polygons on polygons. So now let's have a look at several examples that you could understand it more clearly. So the first example, when we have a point layer having a points from 1 to 7, and this is an attribute table of this point, so where you have ID and corresponding attribute. In this regard, each point represent the depth of the well. And our second layer is the polygon, which represent the soil type for the same area with corresponding ID and 3 soil types: clay, loam, and sand. And our operation is to overlay this point layer with the polygon layer. So in GIS, the first step how algorithm works, it decides which points lie in which polygons. So the first operation of line of intersection between point and polygons is performed as previously explained. Then all attributes are transferred from the polygons to those points that fall within those polygons. So yeah, only attributes of those polygons that where the point lie are then assigned to the corresponding point. And the result is point layer with the original attributes plus attributes from polygon. So, for example, here we have ID numbers of all wells. As you remember, we had them 7. Each well depth is there, so this attribute is preserved. And in addition, we received as an additional attribute of that comes from the polygon layer. So which soil type belongs to which well. And please note that the opposite is not possible. So you can't transfer polygons attributes to the polygon using this overlay. You have to use other GIS operations, mainly attribute table operations such as attribute table join. Well, there is second type of vector overlay, which is overlay of lines on polygons. And in this regard, we have one layer, which is a vector layer with the lines, so lines. And we have three segments within this line, which show the length of the stream. So 1, 2, 3, and corresponding attribute shows the length of the stream. And we have a polygon layer showing the IDs of different parcels, which have attributes of ABC. And we would like to overlay this two. So what is going on in this regard? When we overlay our line layer with the polygon, the first decision should be made which line segments fall into which polygons. Then the attributes from the polygons are transferred to those parts of the line segments that fall within them. Yeah, so again, um, the new start and end nodes are established and lines divided into smaller lines, and calculation of intersections is required, lines divided into smaller lines. Yeah, so if you see here, we have in the initial layer only three segments, but due to this overlay, each overlay with each of the polygon produced a new line segment, and the stream length would be assigned here to each of this line. But be careful. Well, for example, our first line is 1, and the attribute is preserved from the previous attribute table. So our previous line here had a length of 24 meters. But once we have overlaid our attribute of line 1, which is here, is now divided into 4 new segments, though the attribute remains the same. So you have to really understand what is going on, not to be surprised and not to erroneously then use this information for your further computation. Well, and for each of these newly created segments, the corresponding land parcel is attribute for land parcel is assigned. And by the way, the output of line on polygon operation is a line layer, while the output of the point on polygon operation is a point layer. And our last type of overlay or vector of overlay is polygons on polygons. And here we have a simple example when we would like to overlay two polygons, one with the two polygons layer. The first polygon layer consists of two polygons showing the county in Sweden, Lund and Malmö. And in the second, we have polygon layer. We have also two polygons show the radon concentration in this area, which is low and high. And as a result of the polygons and polygons overlay, the first all points of intersection between all 4 polygons are assigned, and new nodes for polygons are calculated. New polygons are then created with the attributes from both input layers. Well, as you can see, as a result, we have a layer which has 4 polygons instead of 2, with each of these polygon now stands to the overlaid, between both of these polygons, and have attributes of both previous polygons. Something to note that this kind of operations, polygons and polygons, could be computationally very intensive. So in our example, this is not really the case because we're just dealing with 4 polygons. But in the case when you have a lot of polygons, for example, you would like to overlay crop fields from within 2 counties, then this operation could be a bit computational intensive and take some time. And as a result of this polygons overlay, what is a common problem which you could observe is the creation of so-called slivers. Slivers are very small polygons that are result when two polygons are overlaid. So in this example here, we don't have this, but no, in the next video, I'm going to show you. So basically, those are very small polygons that result into by this operation, polygon and polygon overlay, and usually we have then to apply pre-processing or post-processing steps to remove those slivers.